Right, example 19, 5 to the 3/4 power. That's the same thing as the fourth root of 5 cubed. That's acceptable. Also, you could write it like this also. Both of these are correct. Looking at example 20, 3 to the 1/5 power, that's the same thing as the fifth root of 3 to the first. Now, the first really isn't needed here, but you could put it there if you wanted. Example 21, rewrite each expression in rational exponent notation. So the third root of 11 is the same thing as 11 to the 1/3 power. 22, the fifth root of 12, all squared, is the same thing as 12 to the 2/5 power. Now, I don't know if you've noticed this or not, but that little tiny number that's in the wedge there of the radical, so here it's a 3, here there's a 5, that number is always going to be your denominator. Hopefully you picked up on that. Example 23 here, we have the third root of 9 times the third root of 3. Now we can actually multiply these because they're both the third root. So we're going to start by doing third root of 9 times third root of 3, which is the third root of 27. The cube root of 27, well, that's just 3. And if you didn't have that memorized, you could just plug that into your calculator. Example 24, we're taking the fourth root of 32 divided by the fourth root of 2. Since they are both a fourth root, then we can divide. The fourth root of 32 divided by the fourth root of 2 is the fourth root of 8. And the fourth root of 8 is 2. You could use your calculator for that one also. Let's see, example 25. Here's what you could do. Oh, I'm noticing something as I'm thinking about how am I going to solve this problem. We have the square root of 32 times the square root of 2. I'm going to go ahead and multiply those. 32 times 2 is 64. So we have the square root of 64. And the square root of 64 is 8. That's your final answer. Example 26. The third root of 25 times the third root of -5. That would be the third root of -125. Now, if it's an odd numbered root, you can take the odd number of that particular root. And this answer is -5. And it makes sense if you think about it. -5 times -5 times -5 is -125. Therefore, the cube root of -125 must be -5. All right, before we do example 27, let's take a look at example 28. We are doing 5 to the 1/4 times 3 to the 1/4. Now, since these have the same exponent and different bases, we could go ahead and multiply these. And if you might be thinking, wait, what? We can do that? Well, let's remember that the 5 to the 1/4 power is the same thing as the fourth root of 5. 3 to the 1/4 power is the same thing as the fourth root of 3. And we've already worked a problem recently where as long as we have the same number root, you can multiply these numbers. So this is the same thing as the fourth root of 15. Now that cannot be reduced. So let's go ahead and convert it back to exponential form. 15 to the 1/4 power. Okay, now let's go back and take a look at 27, where we have 3 to the 1/4 times 3 to the 1/2. Now we cannot multiply these numbers like we did the previous problem because now we have different exponents, but the bases are the same. So we're going to apply our law of exponents here. If we're multiplying a problem that involves exponents, we add the exponents. So we're going to do 3 to the 1/4 plus 1/2. Friendly reminder, you're able to use your graphing calculator in the entire thing. So if you don't know how to add these algebraically on paper, then you can just use your graphing calculator. And our final answer would be 3 to the 3/4 power. Example 29. 3 to the 1/3 times 2 to the 1/3. Since we are dealing with different bases, but their exponents are the same, let's go ahead and multiply the bases. So 3 times 2, that's 6. 6 to the 1/3 squared. And now power to power rule. 1/3 times 2 is 6 to the 2/3. That's your final answer there. All right, example 30. 4 cubed, that's 64, times 2 cubed, that's 8, all raised to the negative 1/3 power. So let me do 64 times 8, 64 times 8. That is 512. Okay, I'm going to take care of the negative property of exponents. All right, I took care of the negative property of exponents. So 5/12 became 1/512. The negative is gone. And now 1/3, a power of 1/3, that's meaning you're having to cube root everything inside the parentheses here. So we have to take the cube root of 1 over the cube root of 512. The cube root of 1 is 1, and the cube root of 512 is 8. And now we have our final answer. Example 31, here we have 7 to the first power over 7 to the 2/3 power. Okay, the division property of exponents states that we are going to subtract these exponents. So this here is the same thing as 7 to the first power minus 2/3, which would give us a final answer of 7 to the 1/3. 32, 6 to the 1/4 over 2 to the 1/4. Therefore, we can go ahead and divide these bases. 6 divided by 2 is 3. So now we have 3 to the 1/4 raised to the third power. And now we're going to multiply these two exponents together. 1/4 times 3 would be 3/4. So 3 to the 3/4 power. Example 33. We have the square root of 4x plus 1 is equal to the square root of x plus 10. Now what we need to do is we need to square both sides of the parentheses. And if we do that, it's going to eliminate the square roots. And now we're going to solve for x. Subtract x, bring it over here. Subtract 1, bring it over there. Nine over 3 is 3. At example 34, the cube root of 8x minus 3 equals -7. You're going to first add 3 to both sides. If I add over the 3, -7 plus 3 is -4. Okay, we need to eliminate that cube root by cubing both sides of the equation. And -4 to the third power is -64. Divide away the 8. X equals -8. Example 35. Let's start this one by cubing both sides of our equation, leaving us with x minus 16 equals 2. And now add over the 16. And we have our final answer, x equals 8. Strike that. I realized that I made a mistake. Whenever I cube rooted this problem, it eliminated the cube root here, but I forgot to cube the 2. 2 cubed is 8. So this is the problem that we're solving now. Forgive me, y'all. Sorry about that. All right, now add over the 16. If I add over the 16, that's going to give us 24. That should be your answer there. By the way, if you notice I make any errors on here, just please talk to me during class. I'd be happy to go over it. And if I made an error, I'd be happy to correct that. Example 36 here, we're going to start by subtracting both sides by 11. Subtract over the 11, that's going to give us 3. Next, we're going to square both sides, leaving us with 9x equals 9. Then divide both sides by 9. Final answer, x equals 1. Here we're going to 37 solve the equation and check for extraneous solutions. To start this one, we're going to have to square both sides. Hopefully I don't make the same error I made earlier. Okay, here that eliminates the root, leaving us with 3x plus 4. And x squared is x squared. All right, now I'm going to set this equation equal to 0 by subtracting over the 3x and subtracting over the 4. Now we have a trinomial that we can factor. Since the leading coefficient is 1, I'm going to take the shortcut here, save ourselves some time. All right, now if you set each of these parentheses equal to 0 and solve, we're going to get x equals -1, and we're going to get x equals 4. Now it tells us to check for extraneous solutions. I'm going to go back to the original problem. I'm going to write that down. It was square root of 3x plus 4 equals x. All right, now what we're supposed to do is we're supposed to take each of these numbers and substitute them here and begin solving. And as long as the number is 0 or greater, it's going to work. Well, here, it's just x on the side of the equation. There's nothing to solve. So this is the easiest one to do. If I plugged in 4 here, well, that's greater than or equal to 0. So 4 is a solution. If I plugged in -1, well, -1 is not greater than or equal to 0. Therefore, this one is the extraneous solution. But example 38, in order to solve that one, you have to, in order to get rid of a third power, you're going to cube root both sides, leaving us with x equals 4. The cube root of 64 is 4. Example 39. So that one there, you're going to have to take the 4th root of both sides of the equation. Now that would leave us with x minus 5 equals the 4th root of 16 is 2. Now add over the 5. X equals 7. Okay, 40. What is the value of the 5th root of 32? This you could plug directly into your calculator, but that would give you an answer of 2. What is the value of the cube root of -125? Also, you could use your calculator, but that's -5. What is the value of 128 to the 0 power? For number 42, also you could use your calculator there, but anything to the 0 power is 1. 43. Rewrite the expression in exponential form. So we have log base 4 of 64 equals 3. In order to convert to exponential, we're going to do this number raised to that number equals that number. So here it is, 4 raised to the 3rd power equals 64. And if you follow that exact same pattern for examples 44 and 45, that would give you these answers. So for 44, it's going to be 2 to the 5th power equals 32. And for 45, that would be 4 to the 0 power equals 1. Example 46. This one here, you could use your graphing calculator. If you don't remember how to do that, please let me know, and I'll happily show you once again. But you don't need to. log base 5 of 25 equals what? What does that equal? Here's what a logarithm is. They're pretty much asking you 5 to what power is 25? Well, it's the second power, of course, but it might help to convert to exponential. 5 to what power is 25? This is also a good opportunity for me to remind you of how to use change of base in order to solve these, or with common base. We're going to use a common base of 5 to help us solve this problem. I want to leave 5x alone because we're using base 5. And then if you remember your perfect squares, well, 5 squared is 25, isn't it? So 5 to the x power, 5 to the x power, no change here. 5 squared is 25. So we didn't really change the problem much, but now we can solve it. Now that we have a common base, you can get rid of them and you only solve the exponents, if there's anything to solve. 47. 3 to what power is 27? Well, that's the third power. Log base 2 of 16. 2 to what power is 16? That's going to be the fourth power. 49. This would be a good one for us to do algebraically. Okay, so for 49, we're doing log base 64 of 4 equals what? What does it equal? Let's see. I'm going to convert to exponential. 64 to the x power equals 4. Let's use a common base here. This is where knowing your perfect cubes comes in handy. 4 cubed is 64, but let's remember, there was an exponent of x that we need to include. And 4 to the first power is 4. Now that we have a common base, just solve the exponents. Final answer, 1 over 3. Example 50. Log base 5 of 1. 5 to what power is 1? Anything to the 0 power is 1. Log base 25 of 5. 25 to what power is 5? Well, that's going to be the 1/2 power. The square root of 25 is 5, or the 1/2 power. Okay, 52. Notice on both sides of the equation, we have a logarithm with a common base of 10. So we don't really need them anymore. We can cancel them out, and we're just going to solve whatever's remaining in parentheses. Going to subtract 2x, bring it over here. Subtract 9, bring it over there. Divide both sides by the -1. X equals 4. Example 53. Now, we do not have a common logarithm on both sides of the equation, so we're going to have to convert to exponential here to solve this problem. We have 3 to the second power equals 5x minus 1. Well, 3 to the second power is 9. Now we can solve for x. I'm going to add 1, bring it over here. 10 equals 5x. Divide both sides of our equation by 5, and we have our final answer. X equals 2. For section 55, what function has the domain of all real numbers except -5? What that means is you're going to set all of these denominators equal to 0 and solve. Now I'm going to go ahead and go to the one that is the answer, okay? This one is going to be our answer here. Now, as I mentioned, whenever we're trying to solve for what function has the domain of all real numbers except -5, and if you see x anywhere in your denominator, just set the denominator. And here I'm using x plus 5. That's the denominator here for example D. And I'm going to set it equal to 0, and we're going to solve for x. X equals -5. What that means is x can be any number in the world, but it can't be -5. So we have found our answer. Okay, there's a few different methods you could go about solving this one, and I'm going to try and just keep this as simple as possible. What I'm going to do is I'm going to multiply my numerators first. Let's do 16 times 22. Now, part of the reason why I'm using this method is because you can use your graphing calculators on this. If you weren't allowed to, I would employ a different method, but we can't. So we're going to keep this pretty simple. 16 times 22, that's 352. All right, now a squared times a cubed is a to the fifth. Remember, if you're multiplying exponents, you add the exponents. B times, ooh, there's not another b over here, so let's just carry the b. And then c squared. All over, now I'm going to multiply my denominators. 11 times 4, that's 44. A times, there's not another a. B times b cubed, that's b to the fourth. C times c squared, that's c cubed. Okay, now let's see. 352 over 44. I'm going to reduce that first. 352 divide 44. That's 8. So we have 8 a to the fifth over a. Here we're dividing, therefore we subtract the exponents. That's a to the fourth. B to the first over b to the fourth, that's b to the negative third. C squared over c cubed, that's c to the negative first power. Now, anything that has a negative exponent, we now need to flip. So we're going to have a final answer of 8 a to the fourth over b cubed c to the first power. So it looks like example C is going to be your answer.